Question 3. A student planned and carried out an experiment to determine the enthalpy of reaction when magnesium metal, here, displaces zinc, so we've got some zinc ions, from an aqueous solution of zinc sulfate, so it's making magnesium ions and zinc. The zinc uses this method. A measuring cylinder is used to transfer 50 centimeters cubed of a 1.00 mole per decimeter cube, so that's interesting. I've got a volume and a concentration, must want me to work out moles of aqueous solution of zinc sulfate, wants me to work out the moles of zinc sulfate. Thermometer was placed in the beaker, 2.08 grams of magnesium powder added to the beaker. The mixture was stirred and the maximum temperature recorded. Starting temperature, end temperature. Show by calculation which reactant was in excess. So first of all, as I say, I've got a volume and a concentration. I need to work out number of moles of zinc sulfate. So let's do that first of all. Volume's got to be in decimeter cubed, not centimeter cubed. So to take a small unit value like centimeter cubed up into decimeter cubed, then I'm going to have to divide by 1,000, so 50 divided by 1,000, 0.05. Concentration is moles divided by volume, so 1, which is the concentration, equals moles divided by 0.05, which is my volume in decimeter cubed. Multiply the two numbers together to get moles 0.05. Now, magnesium then, so I've got 0.05 moles of zinc sulfate. It wants me to find out which reactant was in excess. What information I've got about the magnesium? I've just got the mass, but I know it's magnesium, and I know magnesium has got a mass number of 24.3, so moles equals mass over mR. So moles equals mass over mR, moles equals the mass, 2.08 grams, divided by 24.3, 0.0856. So I've got 0.05 moles of zinc sulfate, I've got 0.0856 moles of magnesium. So there's more moles of magnesium than there are zinc sulfate, therefore the magnesium is in excess. So that's for that mark there. Use the data to calculate the experimental value for the enthalpy of reaction in kilojoules per mole. Assume the specific heat capacity. Well, I've been given a specific heat capacity, 4.18. The only equation I need to use now is delta H equals minus MC delta T. So the temperature change, I've got the temperature at the start and the end. It's gone from 23.9 up to 61.2. So subtract that 2, I've got 37.3. That's going to be in Kelvin or degrees C. It doesn't really matter because a temperature change in Kelvin and a temperature change in degrees C is exactly the same. Specific heat capacity is C, that's 4.18. Mass is the mass of the liquid. So density of a solution, so something that's mainly water, 50 centimeter cubed is 50 grams because the density of water is 1. So I've got 50 grams of water. So M is 50, so delta H equals minus 50 multiplied by 4.18 multiplied by the temperature change, 37.3, 7795.7 joules. It wants it in kilojoules per mole, so joules up into a larger unit value of kilojoules, then I've got to divide by 1,000, so if I divide that by 1,000 it's 7.796 kilojoules. That matches what I'm asked for it in kilojoules. So 0.05 moles of zinc sulfate produces 7.79 kilojoules. What I do is I divide both of these numbers by 0.05, so I take the 0.05, divide it by itself. That means 0.05 divided by 0.5 is scaled up to 1 mole now, reacts to produce 7.796 kilojoules divided by 0.05 is 156 kilojoules per mole. It's going to be exothermic, so it's minus because the temperature has gone up. So it's minus 156 kilojoules per mole. And I'll put it to 3 significant figures because all of the other values are to 3 significant figures. Another student used the same method and obtained a value of enthalpy of reaction of minus 142. The data book value for the enthalpy is minus 310. So why did they get an enthalpy change less than it should be? And the answer is there's been some heat loss. So there's been some heat loss, and that's why not all of the some heat loss has been lost to the surroundings, and the temperature change hasn't been measured sufficiently on the thermometer. Suggest how the student's method and the analysis of the results could be improved in order to determine a more accurate value of the enthalpy of reaction. Justify your suggestions. We've already said that the main error, or one of the errors, is heat loss. So let's insulate the beaker or use a polystyrene cup. Use a lid, draw a graph of temperature against time and extrapolate the temperature back, and therefore you can find a temperature rise at a certain time, such as 4 minutes, repeat the results and take an average.